How did the moon form? Earth's moon was born out of destruction. Several theories about our moon's formation vie for dominance, but almost all share that point in common. Near the time of the solar system's formation, about 4.5 billion years ago, something, perhaps a single object the size of Mars, perhaps a series of objects, crashed into the young Earth and flung enough molten and vaporized debris into space to create the moon. The early solar system would have been a chaotic, terrifying place. Debris left over from the formation of the sun coalesced into a disk around the star, creating clumps that ranged in size from dust flecks to minor planets. Gravity drew these objects together, causing them to crash into each other, violent smash-ups that could end in obliteration or new, larger objects. Those mashed-together objects make up the planets, moons, asteroids, and other solar system objects we know today. Visiting the moon with the Apollo missions in the late 1960s and early 1970s revolutionized our understanding of the moon's origins. Previous concepts that the moon was an object captured by Earth's gravity as it sailed by, or that the moon formed alongside Earth from the same debris, fell out of favor after the Apollo missions brought back data and 382 kilograms of lunar samples to Earth in the late 1960s and early 1970s. The Apollo evidence all pointed to the moon forming from a large impact. The age of the rock samples indicated that the moon formed around 60 million years after the solar system began to form. The type and composition of the samples showed that the moon had been molten during its formation and was covered with a deep ocean of magma for tens of millions to hundreds of millions of years, an environment that would occur in the aftermath of an intensely energetic impact. Lunar rocks were found to contain only small amounts of elements that vaporize when heated, further indicating the moon could have formed in a high-energy impact that let those elements escape. Perhaps most importantly, the rock samples indicated that the moon was once a part of Earth. Basaltic rocks from the moon's mantle have striking similarities to basaltic rocks from Earth's mantle. The oxygen isotopes and other elements sealed into the specimens matched those of Earth rocks too precisely for the similarities to be a coincidence. Meteorites make up another body of evidence. Samples collected by Apollo astronauts come from just a few sites on the moon, but lunar meteorites, rocks sent into space by impacts on the moon that eventually find their way to Earth, provide samples from all over the moon that tell a similar tale of the moon's history. Meteorites originating from asteroids have also been used to help confirm the timeline of the moon's formation. Some show signs of having been bombarded by debris from the giant, moon-forming impact. Finally, more recent studies add evidence for a high-energy impact that resulted in the creation of a molten moon. Analysis of light reflecting off the moon gives details of the mineral makeup of the moon's surface, and it shows the widespread presence of anorthosite, an igneous rock that crystallizes out of and floats to the top of magma. The presence of anorthosite across the moon's surface reinforces that the moon must once have been covered by a widespread magma ocean that was quite deep, from hundreds to thousands of kilometers. Thank you for joining us on this cosmic journey through the giant impact hypothesis. If you enjoyed this video, don't forget to like and subscribe for more mind-blowing space exploration content. And as always, keep looking up to the stars, because the universe has countless mysteries waiting to be uncovered.